Okay, hi, it's me again, with sequential extractions again, but for a slightly different purpose and with a different protocol. So, as mentioned before, this afternoon, and my talk specifically, is about soil organic carbon and how enhanced weathering can help stabilize or destabilize soil organic carbon. Okay, the method, you have heard of it, sequential extractions. However, we did this a bit differently. So we added potassium sulfate, and then sequentially sodium pyrophosphate, and finally hydroxylamine hydrochloride, which is similar to the previous protocol. Now, why did we do this? So the idea is that we sequentially extract progressively more chemically stable organic carbon that is more or less then stabilized by minerals. Now, going a little bit into what each extraction means and what pool it's supposed to target. The exchangeable, so the first extraction step that we termed exchangeable is targeting soil organic carbon that is weakly bound to the soil exchangeable complex. Then we have the second fraction, so the sodium pyrophosphate fraction, which is aimed at targeting soil organic carbon bound to organo-metal complexes, which are complexes in solution that can then precipitate and or amorphous metal, oxide, and hydroxide phases. Finally, the third fraction, the hydroxylamine hydrochloride, should target soil organic carbon that is bound to short-range order minerals and other non-crystalline or poorly crystalline phases, so minerals that form at intermediate stages of weathering or soil development. Okay, so what were we wondering? As I mentioned before, the research question was whether enhanced weathering stabilizes or destabilizes soil organic carbon in the soil. But also what we were wondering, and what the aim of this afternoon is, right, is to check whether the results from the sequential extractions are actually comparable to other methods that are combined or thermal methods to see actually what enhanced weathering does to the soil organic carbon. So in order to do this second part, we had to extract enough organic carbon in each fraction to actually also measure it with these other methods that Matilde and Manu and Malte will talk about later. And actually, what they needed, based on our concentration, and we did a preliminary analysis, was 200 milliliters. However, our maximum that could be held in the Falcon tubes was 50. So then what did we do? Our approach was that from one pot, we actually sequentially extracted or leached 4 times the 50 ml to get to the 200. And afterwards, from each of these 4 technical replicates, we subsampled 5 milliliters. And finally, we pull them together. Therefore, once again, there is a lack of biological replication because we only had 1 pot, and technical replication because we pulled the sample together. However, the samples can be at least a little representative of the soil heterogeneity because it's a pooled sample. Okay, now going into the results. Okay, so in this first figure, we have the feedstocks as I was presenting them also in the first presentation. Then we have in the first column the first extract, so potassium sulfate. Then we have sodium pyrophosphate, and then hydroxylamine hydrochloride. And in each row, there's different soils. So what I wanted to show you in this picture is that the sodium pyrophosphate extraction, which is the second extraction, had the highest soil organic carbon concentrations. This is in consistent with previous analysis that we did. So yeah, this was just something nice to check, that there's some sort of correspondence between different soils and experiments. This is, once again, this is the same plot, but it's organized a little bit differently. So on each row, we have the 3 extractions, and actually, on the y-axis, I have allowed free scale, so a bit of what I showed you before with the other extractions, right? Because the different extractions have different orders of magnitudes, and I wanted to allow us to take a look a little bit better. And each column is one different soil. And here what I wanted to show you is that the soil LUFA 2.2 actually had the highest concentrations compared to all the other soils, which checks out because it's the one with the highest soil organic carbon content. And it's always nice to see that things in the sequential extractions check out compared to the soil that you have. This is a plot like before, but with all the different, with the different soils have different axis scales, because I wanted to check if there were comparable treatment effects, even though the amount of organic carbon in the soils are different. So here we take a look a little bit in more detail. This is the same plot as the picture that I showed you before, but only for the first extraction. So this is the potassium sulfate extraction, and what is visible here, which is weakly bound to the soil exchangeable complex. And what is visible here is that the steel slags, once again, are one of the only treatments that show a consistent effect across different soils, with an increase in soil organic carbon linked, weakly bound to the soil exchangeable complex. So in order to see if actually this extraction targeted what we think it targeted, I also checked the cation exchange capacity data that was provided to us from Jens. And here is the cation exchange capacity. And we can see that there's a pretty good match. So I would say that actually this extraction targets quite well the soil organic carbon that is bound to the soil exchangeable complex. Then we passed on to the second extraction, so the sodium pyrophosphate extraction, which you might remember was the largest soil organic carbon pool, which this extraction targets organometal complexes and soil organic carbon that is bound to amorphous oxides and hydroxides. Here, what do we see? Actually, we see the opposite pattern. So the soil organic carbon in the sodium pyrophosphate extraction actually decreases with steel slags in 3 out of the 4 soils. So yeah, this is very interesting results I found. Since this was the largest soil pool, I thought to give it a shot in the dark. I didn't think it was going to work, but I thought to check actually the bulk soil organic carbon just through loss and ignition to see if there was some sort of matching. But of course there was not a big deal. But then we started thinking about it a little bit, and we started thinking about pH. So we thought that maybe the increase in pH due to the steel slag application led to a loss of soil organic carbon in this pool. So this was our second idea. This is once again the soil organic carbon, like I showed before, and this is the soil pH. And you can see that indeed there is a negative relationship between soil pH and soil organic carbon. So we had a meeting with the people from AVI and CDI where we discussed a little bit about this pH effect. I didn't have any answers then. maybe I have a bit more of an answer now, but I'm happy to discuss further. So on one hand, it could be a pH-driven treatment effect. What do I mean here? Of course, we apply the still slags, we increase the soil pH, which can increase the mineralization of soil organic carbon, but also the dissolution of soil organic carbon from the sodium pyrophosphate extraction from that pool, let's say. For example, base-soluble organic carbon can be solubilized by the increase in pH, and therefore we see a decrease of soil organic carbon in the sodium pyrophosphate extraction. On the other hand, which is the question that was brought up by Jens actually, was could it be that the extractants work differentially based on the pH of your sample? So, in other words, if the pH of the soil and the soil plus feedback mixture affects the amount of soil organic carbon extracted in the pool. So, for example, if it works less well in higher pH soil, well, I didn't know anything about this. We've been wondering about pH a little bit. But actually, so I think from what I've seen, and I've looked it up a little bit, this would be the opposite of what would be expected. So with higher pH, more soil organic carbon might be mobilized. So I would think that this differential recovery is not the biggest, let's say, potential explanation for the treatment effect that we saw. Coming to the final extractions, to the final sequentially extracted pool, the hydroxylamine hydrochloride extraction. Here we see a similar pattern as we saw in the first extraction, meaning not across all soils, but meaning that we saw an increase with still slags compared to the controls, right? I haven't looked into this very much just because of time reasons, but yeah, it was once again an increase. So then what I started thinking about is whether the soil organic carbon migrated from the sodium pyrophosphate extraction into one of the other pools, or both other pools, let's say. So the potassium sulfate and the hydroxylamine hydrochloride. And here I have put a slide that is one example of one soil. Others are similar, not all of them have the same, but basically here on the x-axis we have the first two bars that are the potassium sulfate extraction. The middle ones are the sodium pyrophosphate, and finally the hydroxylamine hydrochloride, and they are the upper and lower layer. There's no error bars because the sample size is 1. And on the y-axis we have the difference of soil organic carbon between still slags and the control. So you can see that there is an increase with still slags compared to the control in the first pool and in the second and in the third pool, excuse me. And in the second one, we have a decrease that cannot all be accounted for by the increases in the two other pools. So therefore, there is some soil organic carbon that is unaccounted for that might have been lost, or it's not extracted in these pools because what I couldn't do, because I was sending the samples, I have also sent the remainder of the soil, right? So that can help us probably close the balance a little bit more. Yeah, I think that was everything that I wanted to say. I have some take-home messages. So generally, we saw little effects of the amendments on the soil pools, and no clear indication of chemical stabilization or destabilization across most of the feedstocks. at the time scale that we considered, with the big exception that has been emerging today of the steel slags, which decrease the soil organic carbon in the second extraction, so the sodium pyrophosphate extraction, and increased it in the potassium sulfate and the hydroxylamine hydrochloride. And in general, this effect, the effect of the slags, were generally consistent across different soils. This is a last slide, because I have recently finished my PhD, and I am shamelessly plugging myself. So if you have any job opportunities, not necessarily that you have or offer me a job, but also if you know of something or if you know of opportunities, I am happy to discuss them. No pressure. That's it. Thank you for your attention.